All right, so thank you for that. On to our feature for the night, one of the features of the night. As people may or may not be aware, 50 years ago, in July of next year, July 19, will be the 50th anniversary of the first landing on the moon landing by Buzz Aldrin and Neil Armstrong. So in the lead up to that, we've been doing this monthly sort of look at what was happening in the month 50 years ago. So tonight we're going to be looking at November 1968. Can't believe it. And our series is called Footsteps to the Moon, and it's the countdown to Apollo 11. And this picture, it was in a book that I had when I was 8, and I always thought he looked really miserable, like lugging around whatever he was doing. I don't know. Anyway, that picture really struck me. Looks like he's got his mum's movie camera there too. All right, so once again, the series is basically a series of monthly reports about the lead up to the moon landing, and we'll be culminating in the 50th anniversary of July of next year. So now, the association are working on some events to coincide with that here in Melbourne. There is a big event happening up in Canberra organised by some of the people that were involved in Honeysuckle Creek and the original mission back there. They said they were going to do the last one at the 40th anniversary because they were all getting too damn old, and now they're cycling up to do it again. So it's really fantastic. So if you're not going to be in Canberra, we'll have something here for you in Melbourne. All right, so in addition to the focus on the Apollo missions and the various activities happening around that, we're going to be looking at some of the parallel efforts by the Soviet Union, which kind of happened a lot in secret, and we'll be talking about that. A lot more information has come out post-Cold War and about able to understand what they were doing. We'll also be looking at the Australian contributions to Apollo, including Honeysuckle Creek, Parkes. There's an Australian scientist who did a dust experiment that flew on a number of the missions. He lives in Perth still, and he's very keen to be involved, so we're trying to work out how we're going to get that happening. So the USSR, the Soviet thing, is going to be in February with Igor and Mark Hillier. We've got a TBC to be confirmed in April for the Australian side of it, and also we're going to be looking at the decision to go to the moon using the lunar orbit rendezvous architecture that they eventually went with. So it's quite a fascinating story, and Andrew Rennie is going to be looking at that one for us. But once again, we're going to be looking back at November and the build-up. It's only next month, everybody. You're getting excited? Apollo 8's next month. I wonder how it'll work. Now, I know it's been stressful the last couple of times we've done this. This is where we do the time travel. We go back 50 years. Last time there was a few people who were nauseous and had problems with the G-forces and things like that. So once again, do strap in. It is an exhausting but exhilarating process.
Time machine, what do you mean last time? I mean next time?
Well, yes, last time and next time. So stand by. We made it. November 26, 1968. Give yourself a hand. You made it. Fantastic. All right. Now, let's put ourselves in 1968 and we have to thank our sponsor from 1968. I've got to play this, it's a contractual obligation.
This is the key. The King with soft smoke. Silver King opens the door to a new kind of pleasure. Silver King with soft smoke. Smooth, mild, much more satisfying. Come alive with Silver King. Silver King opens the door to a new kind of pleasure. Silver King.
Why did I ever give up smoking? I don't know. All right, so what was happening in the world in 1968? Well, there was quite an eventful thing that happened on TV. It was the first interracial kiss on commercial US television between Uhura and Kirk. Pan Am flight in Puerto Rico was hijacked and it went off to Cuba and stayed there. It was escorted by a US fighter. Yale University announced it would admit women students for the first time. Things have never been the same since. And in Vietnam, of course, the Vietnam War was raging, and there was a bunch of 374 civilians in Laos were killed in a US attack. It was a pretty horrible time, and they were trying to get the peace talks happening, and so the US pressured the South Vietnamese president to reverse their decision not to participate in peace talks. So eventually that happened. Tricky Dick Nixon won the election. The good old days. When you had a president that could string two words together. Spiro, yeah. Yeah.
His name is an anagram for row of penis.
Hey, this is a G-Rad show. It sounds like it, yeah. Ansett was renamed, Ansett ANA was renamed Ansett. Look at that T-jet. My first ever flight was in one of those. I sat down right down the back, right next to the engine too. God. Anyway, Rain Love will win the Melbourne Cup just recently. And Penelope Plummer, I don't know whatever happened to her, won the Miss World. So I don't know whatever happened to her. Yes. The Beatles won topic still in the US, in Australia I should say. Mary Hopkins was second. Look at those, who's got those singles? With the help of my friend Joe Cocker, he did a good job of that. And the Beatles did release their White Album. And they were just been released, yeah. And they were breaking the law even then. It's shocking. All right, let's look at the space stuff. Okay, so in November, the Apollo 11 third stage was at the static test stand in Sacramento, about to be undergoing testing. The November 3, the Apollo 8 prime crew were in the centrifuge gondola at the Manned Space Flight Centre, not the Johnson Space Flight Centre. And you can see Bill Anders climbing out of there. November 8. Okay, the reason I'm doing this is I just want to impress, and I think I've tried to relate in the last couple of meetings, the amazing number of things that were happening quickly and concurrently, like the decision-making process. Have a look at this. In November 8, they set up a special task group to review all of the hardware and all the processes happening around Apollo 8, where they're going to be ready. November 10, they reviewed the success of Apollo 7 and exceeded all expectations, and they basically said, yep, we can go for this, we can do it. So then different people gave reports on the launch vehicles, the spacecraft status, the flight plan, the readiness of KSC to support the launch, etc. So then Philip said he would recommend to the Management Council. The next day, the Apollo 8 would go to the moon. So these are the main number of the main decision makers here. Sam Phillips, director of the Apollo program. November 11 gives the go-ahead. So they had they'd put it out there and they were going to go for it. So they put that in with the blessings of all the different decision makers. November 12, the very next day, they make the public announcement. And a lot of this was spurred on by a lot of the activities that they were monitoring on the Soviet side. They'd made the Zond 5 unpiloted circumlunar navigation of the moon, and the cosmonauts on Soyuz 3 rendezvousing, etc. Zond 6, a loop around the moon, etc. So there was a lot happening, and they really didn't know how far they were away from gazumping the Americans. So it was really on. November 14, Jim Irwin, who later flew to the moon and walked on the moon on Apollo 15, along with Jerry Gibbons, was performing a vacuum chamber test in the lunar module test article. You can see him sitting there entertaining himself. Once again, designed to simulate a mission, the descent, the landing and the stay on the moon, and the launch and the ascent back. November 16, the Apollo 8 crew conducted a press conference and spent an hour talking about the mission, what they were going to do, answering questions, etc., etc. So they laid out the mission plan, how it was all going to pan out, what they were going to be doing. By the way, as Andrew is fond of saying, this correlation or scale is nowhere near what really is between the moon, the Earth and the moon. Like the moon would be the next building or next few rooms away. Frank Borman, using some state-of-the-art audio-visual aids, was explaining what was going to happen in the mission. At the same time, once again, the Apollo 11 spacecraft was at Downey being fitted out for its mission, hopefully in July. So it looks pretty empty at that stage, but it's being built and constructed. November 20, Fred Hayes, the lunar module backup pilot for Apollo 8, was suiting up for egress tests at 39A. So at that stage, Armstrong, Aldrin and Hayes were the backup crew for Apollo 8. Collins was still undergoing or recovering from his surgery he had to his neck, and so he wasn't confirmed to be the backup for Apollo 8 or indeed the prime crew for 11 at this stage. Once again, this is 1968 November we're talking about. The lunar module for Apollo 9, the first flight of a manned lunar module, was at KSC being readied and having its landing gear fitted. So that was kind of the context of what was happening in Apollo in November, getting ready for the mission next month of Apollo 8. So because there was no mission flying this month, November, we thought we'd take a look at the various training techniques and systems that they used to train the astronauts. People might recognise this bloke. We'll talk about him later. So basically what they did in practice, they practiced every second of the mission, from mundane things like planting the flag to all of the important things like launching, landing, rendezvousing, etc., etc. They used multiple different techniques and different ways of trying to replicate different parts of the mission, including post-mission if they landed out in the water, in the desert, in the jungle, etc., etc. And we'll look at all of that. So this particular one was the fun part of the presentation about training. This was an Iron Cross simulator back from the late 50s. And basically it was a way of trying to train the operator to stabilise and move. So you can see the thruster here moving on the side. This happened to be just a jet sitting in the back there. I don't know why that's there, but anyway. Fascinating. So this is Langley. They've got a couple of fire extinguishers there, which looks high-tech as well, so that's good. All right, so training for the moon. So I'm going to go through some of the different things. So they had indoor moonscapes. So they would spend a lot of time in facilities basically working on the sequence of the moonwalk, getting in and out, equipment deployment, what they were going to do, how they're going to photograph it, who's going to do what, how they're going to work together, what things they would do separately and individually. That was an interesting one. This is Apollo 12 obviously helping him get up from falling over, I assume, just to see how that would work. Now, once again, this is in 1G, so obviously it's not fully replicating the moonwalk experience, and they're basically wearing moon suits, so they would have been pretty heavy to be walking around with as opposed to 1/6 gravity. Yeah, so I spent a lot of time doing that. This is interesting. I saw this is like 1 week before the launch of Apollo 11. This is Neil going through some last-minute processes and steps of his eventual step down the ladder and on the moon. So I'm not sure whether he's wearing his flight suit there. Maybe he was wearing his actual flight suit to make sure it was going to be able to step up and step down. I guess it's an important part of the mission. 6 Degrees Freedom Simulator. This was a contraption that strapped to their backpacks in this case and allowed them to take 5/6 of their weight off of them, so they could practice that bouncing and walking around. Obviously carrying some equipment, but also going up and down a slope, except there's Ed Mitchell here on the right-hand side. I thought that was quite fascinating. In fact, I have to admit, I used to replicate moonwalking myself when I was little. I used to go to the pool, and if you go to a swimming pool and go to about chest deep in water, you can just about replicate that bouncing up there. You don't quite get the same movement forward, but try it next time if you've got a swimming pool. Other training vehicles, the Lunar Landing Research Vehicle. This was basically a vehicle designed by Bell Aerosystems, and it used a jet engine with a thrust pointing directly down. And what they do is they get up to a certain height, 1,500 feet, and then throttle back and basically use the thrusters on board to simulate a moon landing. And they said it was very valuable. In fact, I've got a really nice video here that I thought you might like to see.
Moon and returning it safely to the Earth.
Soon after President Kennedy's call to go to the moon in 1961, a number of researchers began to think about the various aspects of a lunar flight. NASA's Flight Research Center at Edwards proposed a free flight lunar landing simulator program. The research test vehicle was intended to investigate the inherent problems of lunar descents where there is no drag and weight is only 1/6 of Earth. The proposed technique for simulating the lunar gravity installed a jet engine underneath or within the machine on gimbals, so the thrust was always vertically upward. The engine thrust would then be adjusted so that the craft's net weight, that is its gross weight minus the engine thrust, would equal its lunar equivalent. The force required to lift the net weight would be provided by throttleable rockets. The first flight of the LLRV in October of '64 was flown by Joe Walker. First liftoff was what you might call tentative. The second was considerably smoother. During the following year, Joe Walker and Don Malik flew about 150 development flights, expanding the flight envelope and investigating the adequacy of the design and the systems. An advanced version of the LLRV, the Lunar Landing Training Vehicle, or LLTV, proved to be an excellent simulator and was highly regarded by the Apollo lunar module crews as necessary to lunar landing preparation. Typically, the pilot took off with the gimbals locked, flew out to the inner marker, which in this case was about 400 to 500 feet altitude, about 1/4 of a mile from the intended touchdown spot. Arriving at the IP, he began a descent toward the target, switched into the lunar simulation mode, energized the lift rockets, and practiced a lunar landing. I was most fortunate to be involved throughout the entire lunar flying development. I had the pleasure of flying every one of the machines, the LLRF, the ground-based simulators, the LLRV, the LLTV, the lunar module, and even the Weber ejection seat, the last not by choice. NASA management was forever worried about the reliability and safety of these machines and continually wanted to shut them down. But the pilots insisted they were vital to lunar landing preparation, and they prevailed.
Anyway, I thought you'd like that. Did I leave my... So, a less dangerous but somewhat similar way of trying to train for the landing was this Lunar Landing Research Facility. Basically, this system used cables and a frame to sort of take that 5/6 of the weight of the vehicle off, and actually use engines. It had jet engines to use and thrust up and down to be able to take off and land. And once again, it used thrusters as well. So that was quite a fascinating device as well. I don't remember if this has got audio. We'll see. No, it doesn't. So you can see it sits on this big frame, and the spacecraft, or the vehicle, is on those cables. And once again, there's a jet engine underneath it, which increases or decreases the thrust and allows it to raise or lower according to the pilot's inputs. It also has thrusters to be able to turn and go forward, etc. So it's quite a good, effective tool in conjunction with the LRTV. This facility at Langley is still there, and they still use it to this day. They use it for dropping capsules, they use it for the Orion, they use it for flying planes into simulated crashes, etc. And it's proved its worth over the years. You can see the thrust on the ground there. Hey. Skip to the next one because there's another video, but the reason I'm showing this is very specific. So I believe Albean was flying this. And the reason I'm showing this, it's similar to what we saw before. It's an earlier version of the thing. But you'll notice what happens as it gets closer to the ground. They create a surface with craters and things like that to try to simulate everything. But apparently, this particular time, they'd had a lot of rain the night before. And you can see the mist and things coming up. Now, the reason I'm mentioning this is that I read an interview with one of the engineers who spoke to Albean afterwards, and he sort of apologised for the mist and the rain. He said after the mission, when he got back to Earth, he said that training with the water coming up was almost exactly the same as what we experienced on the moon when all the dust came up. So it was actually really good training. Basically, they couldn't see really anything. So it's fascinating. Okay, so they had a reduced gravity walking simulator as well. And this was strung from the Langley facility, and this wasn't really used for training astronauts. It was more to testing the ability for astronauts, for people to be able to walk on the moon. So they basically hung them sideways, and at a certain angle that allowed them to sort of swing out to simulate the 1/6 gravity. It would be quite an exhausting thing to go, but they had all different straps and things to help them. So yeah, they persisted with this. This is the first one was from 63 and this is 68. So once again, and they even started, this one here, I think, they've got a jetpack on the back and they were actually looking at the feasibility of using jetpacks to get around the moon or in space. So by basically using the thrust of the jetpack. So there's videos around, you can see all that sort of stuff. So it's fascinating. So they also had to train for the possible, well, not possible, they were intending to land on the water. So they had to do training. They wouldn't, no point in just getting at the end of the mission and suddenly landing in water and working out what to do. So they had to try and replicate and test and train, practice everything that they did. So this picture on the left is actually of the Apollo 1 crew, I believe. Yeah, Apollo 1 practicing in a swimming pool. Then Apollo 9 in the Gulf of Mexico. And then at the Manned Spacecraft Centre, they even practice getting out of the space capsule if it had inverted and there was no way around to get them out. They did have a system on the spacecraft where they inflated balloons. If the spacecraft landed in, I think it's called Stable 2, they gave that name to the spacecraft. If they couldn't get it round and the airbags didn't inflate it to right the spacecraft, and there was no rescue ship around, what are they going to do? So they had to practice the possibility of getting out through the top of the spacecraft. So once again, trying to think of every possible contingency in case they had problems. So lunar sample collection. They did a lot of this outdoor practice, digging trenches, picking up samples, working together. Because they're in the spacesuit, it's not like you can just walk down and put things in your pocket and go there. You've got to work as a team. So they practiced working as a team, documenting samples, because documenting each sample was very important as well. You could pick up a rock and just throw it in a bag, but where was it sitting? What part of the BVO was it? What orientation was it to the sun? What was it relating to as far as soil and things like that? So they documented every sample. So they, part of the contingency samples, I think, they made sure that they tried to do that. They also had a drill in later missions. They had a drill into the ground, so they were practicing using that drill and extracting the core samples, etc., etc. And very sun smart in the Florida sun too with that suit. So I don't think we would have to worry about sunscreen. Geology training, so they had to do a lot of that. Not so much, well, I think they did a little bit in the early missions, and some of the astronauts were more or less interested in geology. They felt that they were jet jockeys and who cares about geology. But some of the later missions, some of the later crew got right into it. So they did a lot of training about geology. Is that your Domino's order? So here's the Apollo 12 crew, I believe, practicing. Looks like Albine's carrying all the gear and the commander's out the front pointing in direction. So they're basically out there working on the sequence, looking at rock samples and structures of the terrain, etc. And I think that's Jim Lovell and that's Fred Hayes down the bottom there. Once again, looking at samples, photography, etc., etc. So this is fascinating. Some of the things you find when you're doing this research. At Cinder Lake, they actually simulated. They built a crater field. So they actually got out there and laid it all out and blew up all these explosions and created their own crater field. They dug out some things as well, so just to try and replicate as much as possible what they're going to be experiencing when they get onto the moon. I love it. Airborne training. Obviously, we've all seen the Vomit Comet where they do the zero-G training. But they also did 16G training. So they fly the aircraft in a particular configuration so that rather than taking all the gravity off, they have a 1/6 experience like they would on the moon. So there's Buzz on the left-hand side, and I think this is Mitchell and Shepard on the right-hand side, and that's their rickshaw that they took up to the moon. So I'm not sure anyone knows about those. I'm not sure whether the period of 1/6 gravity was greater than the 0G that you get on the Vomit Comet. I don't know. Then there was training out if they landed in the jungle. So here we see different astronauts. I think they went out to, where did they say they went to? Panama, I think they went to other places. And working on if you land in the jungle, there's no supplies. What are you going to do? How are you going to survive, etc. So there's a few identities here. This is John Glenn and Neil Armstrong. They built their own Coco Hilton, and also crossing rivers and that type of thing. So they would dump them out there with the equipment they've got in the spacecraft and tell them to try to make something out of it. So quite fascinating. But then there's the option of dropping into the desert. So you can see some very stylish astronauts in their parachute material, doing some training out there, and then sheltering in the midday sun in a makeshift shelter while they wait to get rescued. So I wonder if they brought alcohol with them. Probably. All right. So of course, a very important skill in space, in doing an Apollo mission, is rendezvous and docking. So they had to practice, train and test that. So they built various different systems to be able to do that. So one of them was once again at Langley. Langley was involved in a lot of this sort of stuff in building 1244. This rendezvous docking simulator, which went through various iterations, and you can see here it's basically once again a set of cables and a rig to be able to allow them to fly the command module to the lunar module. And this looks like an earlier version of the lunar module up there. So quite fascinating. We've got a little video here, which once again I'm not sure it's got audio or not. I think it does. No, it doesn't. But one of the few times you see the actual things in motion. Yeah, so once again, we dropped over back to the Langley. Might skip forward on that because we've sort of seen that. Now, someone might be able to tell me about this. This is the multiple access space test inertia facility, and these pictures are from '59. Basically, and I think if people have seen First Man, you would have seen Neil and the other astronauts fighting with it. Now, I don't know. I don't see much evidence of this being used in later training, like Gemini and Apollo. I don't know whether they felt it was unnecessary. I don't know. People may be able to enlighten me. But this is the unit here, and this is its in motion. So it's in 3 dimensions, and the astronaut or the person riding it's supposed to be.
But it was used to the movie First Man.
It was, but what context though? Was it in his early days? in the pre-Gemini. I thought so. I hadn't seen anything post Mercury.
Still not sure if the Gemini 8 still was 3 axes. At least 1 axis and most probably 2 axes. I don't know if it was 3 axis.
Yeah, but I don't know whether this training unit was in use at that era, at that stage. Anyway, this thing certainly was used. This is nicknamed the Great Train Wreck, and this was probably the single unit they probably spent most, especially the command module pilot, spent most of their time. This is the command module simulator. This is connected to computers to drive all the displays, react to the astronauts' inputs. It was able to be connected to mission control, the actual mission control, and there was also like a mission control here that was designed to put in errors and problems, etc., throw them at them. So basically what it is, you've got a command module in the centre here with all these optical display units feeding video into the display in the windows. That's quite fascinating. So this is Mike Collins actually in the simulator taking a break, waving a chat to somebody. There was no picture there. So yeah, so that basically had lots of things, and people seen Apollo 13, you would have seen them. They spent so much time sitting there working out how they were going to get them back on the power they had and that type of thing. Once again, brushed over a lot of detail, but that's kind of the facility that was in. When I went to the States back in the early 80s, this was actually still set up in this configuration. It's since been dismantled. The actual spacecraft at the centre of it is, I can't remember where it's displayed, but all this other stuff's not there, stored or somewhere, I don't know where it is. Now, in conjunction with that, there was also the lunar module mission simulator. Very similar type of configuration with all these displays feeding into the windows of the vehicle, of the simulator. Once again, designed to be able to put all the displays in, all the programs, the computer programs, to test things, to run things, to work together. And they would have been working with the command module guy in the command module at that time, and also mission control, either the guys local putting in the different inputs or the actual mission control in Houston, well, in the mission control centre. So once again, I think that display unit is at the. Anyone been over there? Looks like this. I think it's in Huntsville. That particular unit. I think there's more than one of those. There's only one in the command module one, but I think it's two lunar module ones. And this is once again that bloke keeps popping up inside that simulator, working through the procedures. They spent once again a lot of time in there. And to drive the displays for those, back we're talking pre-computer digital graphics and CGI, they basically had built all these models and they basically filmed them with TV cameras and fed them into those simulators. So this is one of the models. There's a whole range of different types of models, 3D models made of plaster and cardboard and wood and all that sort of thing. And they would film them and the camera would move in correspondence with the astronaut's input and the vehicle and in the simulator. And this is the kind of display that they would see out the window. So the astronaut said it was really good quality. So, for 50 years ago to be doing that, it was pretty impressive. Lunar rover. Obviously, the lunar rover was not used early on in the first missions landing, but in the last three, the missions, they did use a lunar rover. So they built replicas of these rovers, obviously to operate in 1G, and they would spend time driving around, working on the procedures in conjunction with setting up experiments and documenting things and how they would go in different locations, etc. Now this is one of the test ones that they built for the Delco Electronics division, GM. Now they also had another one. So this is some fit tests and basically this is Marshall Space Flight Centre. So they had different bits of equipment at different locations, focusing on different things. Okay, so this on the right-hand side, once again, that we saw that picture before. There, that's in at the Kennedy Space Centre. This was an interesting one. I've only ever seen one evidence of it being used. This was called the Lunar Rover Training SMK-23 Flight Simulator. Basically, it was a flight simulator, like a traditional aircraft simulator, but it was modified for use. So basically the way it works is they had the operators here, you can see them sitting here with their Lunar Rover controller, and a surface running on a conveyor belt by the looks of it, and the camera. So basically what they're doing is they're sitting here simulating driving around the rover. I don't know how valuable that training would have been, but anyway, they kind of went through it. So I've got a really interesting little film here. Once again, I'm not sure how much value. We should have asked Charlie when he was here how much value you got out of that, but let's have a look at the film. It's voiced over, unrelated to the imagery, but it sort of talks a bit about the mission and what they...
Expressions of other topographic features. They bend around small craters and big crater walls and things like that. And whether we're seeing always the same thing or whether there's several things that contribute to this effect, I can't sort that out.
Okay, could you see them from 60 nautical miles without the binocular?
I would say no. I really don't remember offhand, but I think not, because it was so dramatic to me when we came down in the parking orbit that as we got closer to the surface they started popping out, and they were very significant at 10 to 8 mile range, but I remember seeing them always, and I think it must have been using the binoculars that showed them up.
By always, do you mean the low sun angle parts of your orbits, or even at high sun azimuth?
Always.
Always.
Like I say, I have the feeling that if I ever found a place that didn't have that pattern, it would be very unique.
Mm-hmm.
In a local area, is there much deviation in orientation?
In the Cayley area where we were?
Any area. Any local
Oh.
area, much deviation in orientation?
Well,
I do apologise for that, but the look on Charlie Duke's face particularly is kind of bemused about what are we doing here with this training. Anyway, some other things. Once again, Lunar Rover. These guys out at the Geological Surveys, astrogeology band, actually went ahead and built for them their own Lunar Rover for use out in their facility. So you can see there's pictures on their website of them building it from scratch, and bolting the wheels on and welding the frame together until they end up with this rover vehicle. And I thought this picture was particularly good. That's the jet jockey Gene Cernan with his cute little beanie on. Must have been cold that day. I thought that was kind of cute. And once again, they parked the Grover and used these sort of handmade sort of backpack mock-ups to be able to work on the sequence of looking for samples, picking up samples, photographing them, documenting them, putting them back. So once again, as the missions progressed, the amount of time on the moon and the sophistication of the geology got more sophisticated. All right. So anyone know what that?
That rover, the USGS, was lunar ran car park in it, and it's cotton.
Oh, is that right? You've seen it, have you?
Yeah, last year when we went over there for the eclipse.
Wow, fantastic. So anyone know what this little thing is? Well, you'll find out. This is James Burke.
Last thing anybody wants now is an emergency. But like everything else, they're ready for that too.
Once the crew are on board, if it looks as if they're in danger, they get out and head down this tube, specially insulated against fire, and zigzagging down not to some point out and away from the rocket, but to an escape room exactly where you'd think it shouldn't be.
Three and a half minutes after they get the warning in the capsule, the crew could be down here in the blast escape room via that 200-foot escape tube, 40 feet below the base of the rocket. They find themselves in a totally rubber room, walls and floors, and they head for safety through a 6-inch steel door. Once they're behind that door, it doesn't matter what comes down this tube behind them. On this side of that door, the rarely seen blast escape room itself. It's totally isolated from everything around it by a series of 24 giant springs underneath the floor and shells all round it of steel, concrete and sand. It contains enough food, water and air for 20 people for up to 24 hours, and it's all round the edge. There are these foam rubber shock-absorbing seats, as you can see. The room is built to withstand the simultaneous explosion of every drop of fuel on a Saturn V. And in that event, strapped into your shock-absorbing seat, if your rocket did blow itself to bits 40 feet above your head, all you'd feel would be a mild rumble from somewhere up there.
All right. So, as usual, there's no way I could have covered everything. I've given you a snippet of some of the things that they did and how they did it and why they did it. I think it's fascinating. But now it's time to turn to 2018, everybody. So once again, strap in. Here we go.
What if I went faster?
And we're back. Congratulations, you all made it. All right, so as you could probably work out, our next meeting in December, we're going to be looking at Apollo 8. The key question is, will they get to the moon? No spoilers. Or will they have a problem? And these are the guys that are in training now to do that mission. The prime crew and the backup crew. And their Saturn V is on the pad as we speak. So we'll find out in the next meeting.